Hi, this is Omar from Drop Consultancies, and this is part 2 of the Astronomy Calculator, which is a program that we have created in Access VBA, and you can download it free from our website. In this video, we'll discuss in more details the azimuth and altitude graphics in this application. Double click. As we have mentioned in the previous video, we have 4 graphic pages in this application. 3 of them are related to azimuth and altitude. This is the first one, which is attached to this data table, and the second one is a larger image of this one. This is the second one, which is almost a single object one. The third one is in options, graphics, and star chart, and this is the third one, and all the 3 are related to azimuth and altitude. The fourth one is different. It is the solar system graphic. In this video we'll speak mainly about the azimuth and altitude and how to read the graphics related to them. Let's speak about the true noon. This is the true Noon GMT for this specific location. If I click here, click to apply, the timing of the new moon being forwarded to the data entry area, and immediately the sun is at the noon position. Let's go for the larger image. What is noon? Noon is the transit of the sun, and the transit of the object is when the object is exactly to the north of us or to the south, and it is at the highest altitude at that day. So at this date, at this location, the sun at noon was about 65 degrees. And to be more accurate, we can look at the table, and the altitude is about 63 degrees, 62.94. But what is altitude? If you are facing the sun or you are facing an object, then the altitude is the angle between this object to the horizon. Now, we can really show that this is the highest altitude. We can use the control panel. Let's have a 0.5 duration. 0.5 hour duration, and let's go for previous. This is about sunrise. Now let's start from this point, and you will see that the sun is rising in altitude, rising until reaching noon. After that, the sun is dropping down. This is why at noon the sun will be at its highest position at that day. Now this position of the sun is not an extreme case for this graph, but in some locations on Earth the sun will be exactly at 90 degrees altitude. And if, for example, the object was here, if you added 1 minute, it will jump from here to probably here. And this is a large distance in a 2D graph, but it is not a large distance in the 3D space, because as we have said in the previous video, this point is actually the same as this point. The altitude need to be viewed as a circle, and it is a circle. Let me clarify this. Suppose you are standing upright and the sun is directly above your head. Then the sun will be at 90 degrees west, which is exactly the same point as 90 degrees east, which is exactly the same point as 90 degrees north, which is exactly the same as 90 degrees south. What I want to say here is that at 90 degrees altitude, all the directions are exactly at the same point. Let us have an example. I'm looking for the declination, and the declination is here. It is 12.84 degrees. What is the declination? We said that about the altitude, if you are facing the object, then the altitude is the angle between the object and the horizon. The declination is the angle between the object and the equator by the center of the earth. So if we had a line from the object, the center of the object, to the center of the earth, then the declination is the angle between this line and the equator. But what does this mean? It means that at this specific latitude, 12.84 degrees, at noon, at this specific date, the sun will be perpendicular to this latitude. That is, the altitude will be 90 degrees. Let us test this. Copy, paste, apply. Let's make the image larger. The sun is exactly at 90 degrees. Let's check that in the table. Altitude is 89.997438. Let's deduct 1 minute only from the time. 1 minute. Previous. See the jump? Next. Previous. Now, this is a large jump in this 2D graph, but it is not a large jump in the 3D space, because this point and this point are exactly the same. Equally, this point in minus 90 degrees and this point are exactly the same. We need to look at the altitude as a circle. It is easier for us in terms of drawing and plotting objects in the graph to make the altitude as this, but in practice it is a circle, and this is what I meant by that the 2D graph require a little bit of imagination. Now, if the object was at a higher altitude, in this extreme case, you will see that the object jumps in its movement. And this is only related to this graph at this extreme case, higher altitude. Now, the object does not jump in reality. The object does not jump in the 3D space. The object always moves smoothly. However, for this graph only, the object jumps at higher altitude because of the design of the 2D graph. However, when the object returns back to 80 degrees, then you will notice that the object movement starts to be smooth. Let's see that. Let's have 1 hour. Click next. This is a huge jump. and then the object returned back to the smooth movement. Now we are reaching the high altitude and we have a jump. Now, as I said in the previous video, this is above the horizon and this is below the horizon. And this is why you see the sun rotating around our location. Let's return back to our original location. I think it was Belgium. Now, it's useful to mention here that all points of longitude, all the location, all the points at the specific longitude will have the same noon moment and the same midnight moment. This is why when we put this latitude at this exact same longitude, it was noon. Though the latitude was different, it was noon. And when we returned back to the original location, it is still noon. Noon is exactly at the same moment at one longitude. Sunrise and sunset will depend on latitude. Different latitude will have different sunrise and sunset timings. Let's have the larger image. We spoke about the altitude. What about the azimuth? What is the azimuth? Suppose you are facing the object and this is your direction to the object. Then the azimuth is the angle from north clockwise to your direction. So we have two angles here. The first angle is the altitude, which is when you are facing the objects, the angle between the object and the horizon, and the azimuth, which is the angle from north clockwise until we face the object. Now, as we said that the altitude need to be viewed as a circle, also the azimuth is actually a circle at the ground. So originally we are at 0. When we look at the graph, we are at 0 facing north, looking at north. This is why it's mentioned here, north in the front of you, south behind you. Now, after turning 90 degrees, you are facing east. Although this looks like a line, but you need to view it like a circle. What we are trying here to do is we are trying to have the best 2D graph that can contain a lot of information about 3D space. But this requires some imagination. And this is why I'm saying that although this looks like one square, it is actually a circle. It needs to be viewed like a circle. So after turning 90 degrees from facing north, you will be facing east. This is east. And this point are exactly the same. And when you're turning another 90 degrees, you are at 180 and you are facing south. And if you are turning another 90 degrees, you are at 270 and you are facing west. And this point are exactly the same. And when you are turning another 90 degrees, you are back at 0 facing north. Now the sun is clarified in this position as south. Therefore, we need to use the lower scale, the southern line. If it was north, then we will use the upper scale, the northern line. So the sun at this position, the azimuth of the sun at this position is 180 degrees, not 0, but 180 degrees. Now, in this graph, we are facing north. North in front of you, south behind you. We are facing north. So the sun is about 65 degrees altitude behind you. Now let us speak about midnight, which is going to be an interesting subject. Click exit. Let's go to summer. Let's go to 21 of June. So April, May, June, 21. And let's go to midnight. This is through midnight GMT. Click to apply. And let's have a larger image. Now the question, what is midnight? When we spoke about the noon, we spoke that noon is the transit of the object, and this happened when the object is exactly to the north and south of us, and it is at the highest altitude. Midnight is the opposite of transit. So at midnight, the sun will be exactly to the north or south from our location, but at the lowest altitude at that day. So the sun at this specific location, at this specific date, at midnight, is exactly to the north of this location with an altitude of minus 20 degrees, which is below the horizon. Now we cannot see the sun because it is below the horizon, but if we can see through Earth, we will see the sun exactly to the north with an altitude of minus 20 degrees, about minus 20 degrees. We can see that clearly here. The altitude is minus 26 degrees, 0.69. If we can look at it, yes, it is about minus 25 degrees. Let's do now something interesting. Let's add 10 degrees to the latitude of this location. Let's put 0 here and let's point to latitude. This is Beijing in China. This is the location of Beijing. Now what we are going to do, we are going to add another 10 degrees to the latitude. So we are going north of this city. Now notice what's happened to the sun at midnight. Click next. It moved, the point of midnight moved closer to the horizon. Click another next. Click another next. Now we are almost above the horizon. Let's put the sun, the midnight point, at exactly the horizon. Previous. Now the center of this circle is exactly at the horizon. Now what you will notice is that the point of sunset, the point of sunrise, and the point of midnight became exactly the same point. What happened here at this particular location, at this particular date, at the time of midnight, that is when the sun reached its lowest altitude, the sun will set, and immediately after that it will rise again. So the sunset point, midnight point, and sunrise point are exactly the same. Let's add 5 degrees to the latitude. So we are now at latitude 71. And at this location, the sun does not move below the horizon. It will always stay, for that 24 hours, it will always stay above the horizon. This is an interesting situation. For me as a Muslim, I'm required to pray 5 times every day and night. We have the noon prayer, afternoon prayer, the sunset prayer, the night prayer, and the dawn prayer. So if the sun doesn't move below the horizon, how am I going to pray the night prayer? Let's explore this situation. Let's add 1 hour to the hour, and let's choose the time. And let's see how the sun move through time in this location at this date. So click next. It's start to rise. Next, next, next. Here is about east. We have the noon point. Now the sun is moving down, returning back to what I can call the midnight point. I'm going to define the midnight point not about night and day. The midnight point is when the sun is exactly to the north or south of us and at its lowest altitude. So although there is no night, still this is the point of midnight, because this is the point at opposite transit and at the lowest altitude at that day. So, looking at this situation, you can see that we have 2 current prayers that we need to pray that day. That is noon. So when the sun reaches noon, we are required to pray the noon prayer. And then we have also the afternoon prayer. The afternoon is when the sun reaches the middle point between noon and the horizon. So when we move with the sun, this is the midpoint between noon and the horizon, and at this particular moment we are required to pray the afternoon prayer. And then when we continue, this is what we can call the midnight point, and then moving up, reaching to noon again. But I cannot pray the next noon prayer without praying the missing prayers. I need to pray 5 times. So between noon and noon there need to be 5 prayers. Now, yes, there wasn't any night, there wasn't any sunset, and there wasn't any dawn, but still I cannot pray the noon prayer, the next noon prayer, without finishing the 5 prayers. So from looking at this situation, it is possible to say that we are required to pray 5 prayers every 24 hours. The current prayers will be prayed at its proper time. So the noon prayer will be prayed at noon, and the afternoon prayer will be prayed afternoon. But we cannot pray the next noon prayer before completing the 5 prayers over the previous day. But there were only 2 current prayers, noon and afternoon. Therefore, the other 3 prayers, I need to pray them as missing prayers. Now, if we go to, let's say, 87 degrees latitude, click apply. In this location, the only current prayer is noon. There is no current afternoon prayer. The sun here is almost circling the sky in a flat circle. From east to west, crossing the noon once every 24 hours. Let's test that. And that's the idea here. We are required to pray 5 times every day and night. And I could say that the meaning of day and night is 24 hours. That is, we are required to pray 5 times every 24 hours. The current prayers will be prayed at its proper time. So in this location, the noon prayer will be prayed at noon. But I cannot pray the next noon prayer without finishing the 5 prayers of the previous day. What I mean here is that between noon and noon, there are 5 prayers. Let's return back to our previous location. And this before, apply. And let's return back to what we called the midnight point. And let us now visualize. We have a 2D image. And let us visualize exactly how the sun moves. From this graph, we want to imagine how the sun moves. So the sun at midnight, what we call midnight point, is at north. But noon is at the south. Let's check it. Noon is actually a point in the south. So the sun is moving in a tilted circle. The lowest point is the north point at midnight point. We will call the midnight point as the north point, and we will call the noon point as the south point. The sun is moving in a tilted circle, starting from the north point almost at the horizon, rising up toward the south point through east. And then when reaching the south point, the sun starts to move down toward the north point through west. Now, in order to imagine the movement of the sun through this graph, you need to realize that you are looking to north. In this graph, you are looking to north. North is in front of you, south behind you. So in this case, if you are looking to north, then at midnight point, the north point is in front of you, very far. And the sun starts to rise up and coming near you toward the east. Rising up and coming near toward the east. At east, the sun starts to move behind you. You are looking to north and south behind you. And at east, the sun starts to move behind you, rising up toward the south point behind you. And at that south point behind you, it starts to move down. And you cannot see it because you are looking to the north. You cannot see it. And moving down until it's reached west. And passing west, you start to see it at your left-hand side. And after that, the sun is just moving down toward the north point. However, in 21 December, in the South Pole, the tilt will be opposite than to the North Pole. Let's make it clear here. The sun in all points on Earth will move from the midnight point up to the noon point through east, and then it will come down from the noon point to the midnight point through west. So it is always from east to west. However, noon in the northern pole is to the south. Noon in the south pole is to the north. Midnight point in the north pole is to the north. Midnight point in the south pole is to the south. So the circle, the movement of the sun circle start in the North Pole from low north to high south, this is opposite in the South Pole. In the South Pole, it will start from low south to high north. But in both cases, the sun goes from midnight point to the noon point through east, and from noon point to the midnight point through west. I hope this video provided you with a guidance of how you can use the azimuth and altitude graph to visualize the movement of the sun around a specific location. I hope this video is useful, and thank you for listening.